If you're struggling with what is the scientific method, this podcast will explain how to use the scientific method steps to perform effective experiments and compile experiment information into a lab report. First, I would like to share with you a little bit of history in regards to the scientific method. Now, scientific method is not just used by scientists, but can be used by anyone who wants to explain or understand how the world works. When we look back at history, the first person that comes to mind would be Aristotle. Aristotle was a philosopher who had a teacher by the name of Plato. Now, the way it worked back then is Aristotle was very, very smart, and he based a lot of the conclusions that he came to based on his intuition and his brain, of course. Because of that, and he was right so much of the time, a lot of people never tested what he said to be true or false. An example would be that if you went on a large building and you dropped two objects, one being a large ball and the other one being a small ball, one weighing significantly more than the other, and you drop them off of a building, what would happen would be the larger ball would hit the ground first because it was heavier. Now, this wasn't challenged until much later with Galileo, and when Galileo came around, he verified that if you dropped the two balls, it didn't matter about the weight, they would hit the ground at the same time. So that disproved what Aristotle said. That happened because Galileo did an experiment, as different than when Aristotle, who just thought how it should be, Galileo actually tested it out. So we're going to talk about some different tests and how that you use the scientific method. Now, today, I know a lot of you have watched Mythbusters, great show, and they aren't scientists, but they are dedicated to finding out how things work and why they work based on experiments. The official definition for scientific method is a systematic approach used by scientists to study and report results. It doesn't matter if it's in chemistry, biology, physics, it is used to compile research and provides a method to verify the work of other scientists. If other scientists cannot perform the results after repeated experiments using the scientific method, then doubt arises as to the validity of the reported results. The main steps of the scientific method are observations, hypothesis, experiments, analysis results, and conclusion. When we talk about observations, just like the Mythbusters, they take something they've seen or thought about and they want to verify exactly what's going on with it. So the scientific study usually begins with a simple observation. There are two types of observations that result in qualitative data and quantitative data. Qualitative data is something you see, color, shape, a physical characteristic. A quantitative data is something that would be measured. Example would be weight, mass, height. Hypothesis really is a statement in that you are giving information in a way that informs into question, which is an if and then statement. Example would be if you boil half a cup of water for 3 minutes, then the water in the beaker will evaporate and the beaker will no longer have a half a cup of water. The next step would be to do an experiment. An experiment is a set of controlled observations that test the hypothesis. The scientist must carefully plan and set up one or more laboratory experiments in order to change and test one of the variables at a time. There are two types of variables. We have independent variables and dependent variables. Independent variables are the variables that you can change. Example would be temperature. A dependent variable would be a variable that changes in response to the independent variable. An example would be salt. The amount of salt that you put in the water could change. And a controlled area would be the sample would be, for instance, in the test tube you use to conduct the experiment. Analysis results. The data from the experiment results needs to be reviewed and compared. When you do analysis and results, it's always good to use a graph. And on the graph, you should always have independent variable at the bottom and the dependent variable on the side of the graph. Conclusion. A conclusion is a statement based on the information obtained. The hypothesis gives a tentative thumbs up to the idea that the hypothesis may be true. If there was an additional information needed to support the hypothesis could be discarded or modified. The conclusion is an opportunity to discuss next steps or other possible experiments that would need to be completed. It identifies any possible flaws in the experiment and addresses what-if situations that need to be considered going forward. Scientific theory. A scientific theory is an explanation that has been supported by many experiments. For instance, Einstein's theory of relativity would be an example of a scientific theory. Scientific law is when a scientist, through experiments, finds no exceptions in the relationship to nature. An example would be Sir Isaac Newton and the law of gravity. Next, I'd like to talk with you about a lab report. Lab reports. One method of compiling the information gained from the scientific method would be a lab report. The lab report is a tool used by scientists to give other scientists a blueprint on how to conduct the same experiment and get the same results. Details are necessary. One format that is commonly used contains the following: a header information, which is the name, the group members are identified, and the date. Next would be the purpose. Why are you interested in this particular area of study? For example, would be evaporation. Second, hypothesis. Hypothesis is an if and then statement. If you boil water, then the original amount of water will not be the same. The next step would be materials. What are the materials needed to conduct the experiment? Include tools to measure and how to capture the results. Next would be experiment or procedures. You list exact steps of the experiment. What you did first, second, third, fourth, fifth, in a concise way so that another scientist can use it as a blueprint. Analysis and results. If the results are qualitative, what exactly did you observe? If the results are quantitative, what are the results? In numerical form, graph results to be compared. There's an overlap in both quantitative and qualitative results. Conclusion. Restate the hypothesis. Was the hypothesis correct? Why or why not? What would you have done differently? Or what was a possible flaw in the experiment? What would you think would be the next sequential experiment? The next most logical follow-up experiment? An example of a lab report is provided. If you have any further questions, you can go online and see the next podcast. Thank you for your time.